Okay, welcome back. I hope everybody has had a great weekend. Remember, on Thursday and Friday each, we were working on section 5.2, and each of those days I gave you 6 problems to do. Today is the final day of that assignment, so a couple of you have went ahead and sent me part of it. That's fine. I'm going to give you a few more problems today, and then all of those will be due tomorrow. Now, just a couple things. If the deadlines are a problem, if you've got something else going on or you haven't got to it, shoot me an email, guys. This is a new situation for all of us, and we're just trying to do the best we can. So I am going to be very understanding. You just have to communicate with me. Second, if you are struggling with this, please reach out to me. There's not much I can do if I don't know that there's a problem. I know it is much easier to talk to me than it is to send an email about a math problem, but we have to do the best we can right now. So please don't hesitate to shoot me an email. Send me a picture of where you got stuck. I can, give you a hint for the next step, show you how to work things out, make a video for you. I can do a lot of things to help, but only if you're reaching out to me and letting me know when you have those issues. So today, I am not doing any new content. I am going to work maybe 4 examples with you, just refreshing how we are working those proofs last week and exactly what I expect on your work. And then I'm posting a handout with 4 more problems. So you had 6 each of the first 2 days, 4 today. So then all of those, all 16, due tomorrow. But again, if that's an issue, just let me know. So let's look at one. And if you think you're doing great with these and you don't want to watch my video, that is up to you. Just make sure you're prepared. One thing I have noticed is some of you are not following the format that I asked for. You have to write down the full problem every time. And I need to see 2 boxes on your problem every time. The first box comes from the original problem. I want you to box in the side that you're working towards. And then when you get that at the end, you should box it in. So if you don't have 2 boxes on your problem, please do that. And we have talked about sometimes if you get stuck, you might work both sides. And so then you would work each side and get the same answer and box those 2 sides in. Our strategies, we look at this and see if there's any obvious formulas, and there are not. So then we change to sines and cosines. Secant is 1 over cosine. Tangent, sine over cosine. Cotangent is cosine over sine. Okay, we have a lot going on here, a lot of fractions. Keep in mind this is like sine theta over 1. So when you're multiplying these, multiply the tops, multiply the bottoms. So that's sine theta over cosine theta. Remember, you are proving to me that this is true, so there's no skipping steps here. You're writing out everything. For the bottom, if you want to add, you need a common denominator. This one has cosine, so it needs sine. So you have to multiply top and bottom. This is sine, so it needs cosine on top and bottom. So when I do that, sine times sine gives me sine squared cosine times cosine is cosine squared. My denominators are sine theta, cosine theta. If you wanted to skip right to that step where you put those in one big fraction, that is also okay. This step right here is an optional one. If you jumped right to this point, that's okay as well. All right. If you want to divide fractions, we flip and multiply. So the second one flips, and we can multiply them together. But this was sine squared plus cosine squared. That is an identity. Sine squared plus cosine squared equals 1. Okay, so now I can see cosine on top and bottom cancel. I have sine times sine, which is sine squared theta. Look back at the original. That's what we were trying to prove. So box it in. 2 boxes. Same thing in both. That shows me I am done with the problem. Okay. Again, I'm just practicing same things we have been doing, so depending on your comfort level, you may not have to watch all of these, but if you're unsure at all, go ahead. It's going to be a fairly short video. Okay, if I'm looking at this one and trying to pick my easier side, there's not a huge difference. Both sides have 2 terms subtracted, so no obvious easier side. I do think the right side is possibly a little bit simpler just because it only has one trig function, it only has a sign in it. So I'm going to box it in. Okay, so that means I'm working with the left and trying to get this for my answer. The left has a sine squared, and I want sine squareds in my answer, but it also has a cosine squared, and I don't want those. I need to figure out something to replace my cosine squared with. So your little thought bubble. Remember, sine squared plus cosine squared equals 1. So if you're solving for cosine, that's equal to 1 minus sine. So that's what I'm going to replace my cosine squared with. Add like terms, -1 sine squared y and -1 sine squared y would be -2 sine squared y. And that was exactly what I wanted. So this problem is done. So box in the easier side, I believe that would be our cosecant squared. Let's work with the left. You do have some options here in terms of identities, what you might change these to. So if you recognize those, great, you can go that route. If not, change the sines and cosines. Just from the few of you that I've talked to, it seems like sines and cosines are where you're most comfortable. So I'm going to go that route. Okay, so secant's 1 over cosine. To clean this up, we've talked about in a fraction, you can multiply top and bottom by the same thing. I'm going to multiply the top and bottom by cosine squared theta. So these would cancel and just give me a 1. On the bottom, you do have to distribute that. 1 over cosine squared times cosine squared is 1, minus 1 times cosine squared. One minus cosine squared is sine squared. Look at your goal. You want cosecant. That is the reciprocal of sine. So 1 over sine squared is cosecant squared. So this particular problem, there are at least 4 different ways of doing it. There's not only one right answer. That's why the work is so important. I have to know how you're getting there. Final example for today. Right, these sides are very similar. The difference is one is multiplying and one is adding or subtracting. We've mentioned before that it's usually easier to get to the multiplication, so I am going to box in the side where it's multiplied. But this would definitely be a problem where if we get stuck, we might come back and work both sides. So if I'm working the right, we could change to sines and cosines. Tangent is sine squared over cosine squared. This is just like sine squared over 1. We're trying to get to a single term, so we need a common denominator, so we have to take this times cosine squared on top and bottom. So that will give me a common denominator. I'm going to go ahead and just write this as one big fraction. If you're looking at your numerator, there are 2 terms, but they do have something in common. They both have a sine squared. So I am going to factor that out, and that leaves me with 1 minus cosine squared. And we are really one step from the answer. Because this is one term on top, you could separate it however you prefer. You could pull that sine squared over cosine squared out. You're left with 1 minus cosine squared, which is sine squared. Sine over cosine is tangent, so we have tangent squared x sine squared x, which was what we wanted. Okay, so again, this was just some review. There's a handout with 4 problems. I would like for all of these problems to be turned in tomorrow. Do not